So we're going to start out, I'm not going to do too many problems from chapter 1, but I did pick a couple from each section. From section number 1, we have 3 of them. One example of interval notation, one of roster notation, and then one on a number line, just because I want to remind you about the empty circles and the filled in circles. So interval notation, remember, looks a little bit like an ordered pair, except it doesn't refer to just one point. It refers to all of the points in an interval. And so we need to look first at the endpoints, -10 to 10. So those are going to be the numbers that we use, comma, again, just like we were going to write an ordered pair. But then the difference between the strictly less than and the less than or equal to. If it has the or equal to, then those are square brackets. It means that that number is included, negative or positive 10 is a solution. If it just has less than or equal to, negative 10 is not included, and to show that a number is not included, we use the round bracket or the parenthesis. So this means all of the numbers between -10 and positive 10. -10 is the left-hand boundary, the lower boundary, but it's not included in the solutions. The square bracket means that positive 10 is included in the solutions. Roster notation is when we list all of them out. This doesn't work always. It would not have worked for this example up here because we can't plot all of those points. We can't list all of those points between -10 and 10. There's an infinite number of points. But since this one just says integers, we can list all of the integers from -5 to +5. So we use those little brackets, the set brackets that are curly, and we just start listing -5, -4, -3, all the way up to +5, and then the other set bracket for the right hand side. And the last one for section 1, use a number line to represent the set. First thing, this has 2 separate pieces to it, so we're going to have 2 different graphs, 2 different lines on our one number line. So the first one, all the numbers between -4 and +4. And like before, this one doesn't have the or equal to. This one does. So when we put our point on -4, if it is not included as a solution, then you leave an empty circle, an open circle. And then it goes all the way to +4. It can be equal to +4. So to show that, we do a closed circle. And so I'm not sure if you'll be able to see my pen, but it's a line in between those. It can be anything in between those two. Or, so also includes anything that's greater than 5. Just greater than, not or equal to. So open circle on 5, and numbers that are greater than 5, larger than 5 are to the right. So this one's not going to have a right-hand endpoint. We just draw an arrow. There's no right boundary for that one.